All right. So this is the cardiovascular unit, and what we're going to be doing today is going through the flow of the blood through the heart, the steps that it takes for the blood to move from the first chamber all the way through the last chamber and through the lungs, and all the moving parts inside. So it is your responsibility to understand how everything moves, including fancy words like contraction, relaxation, systole, diastole, atrial systole, atrial diastole, and so on. So far, so good? Okay, so first thing, it's important to know that the human heart really is merely a pump that pumps blood. It really doesn't have anything to do with oxygen by itself. The heart alone doesn't, the human heart doesn't oxygenate blood by itself. That's the lungs, that's the function of the lungs, the human heart. And it's also important to know that whatever happens on the right side of the heart, what's happening on the left side of the heart is it's happening on the left side is happening at the exact same time, or almost the exact same time. Okay? So when we go through the flow of blood from the right side, and whatever is happening on the right side is really what's happening on the left, is this left side's happening at the same time. Okay? So we really can begin anywhere because it's a cycle. There's no start and stop. But for our purposes, let's just start with the blood coming into the heart, which will be from here and from here. Anybody have an idea of these two vessels?
Superior.
Yeah,
Inferior.
very nice. This is the superior vena cava. The superior vena cava, and your inferior vena cava. Very nice. And we can just kind of put it right here, or maybe right here. Superior vena cava. Very nice. Abbreviated SVC, IVC. Anybody have an idea? This blood moving into the heart, is this blood oxygenated or deoxygenated? Deoxygenated. So blue or red?
Blue.
It's blue. It's blue blood. Very nice. And let's just number these also. So let's give this number 1. Step 1. All right. And there's actually more. It's not just these two that enter the heart. There's actually a few more, but for our purposes, this will suffice. All right. Where do we dump this blood into? Which chamber? Which of the 4 human heart chambers?
Right.
Atrium.
This is you are looking at your patient now. Your patient is looking at you. So what's happening on this side is the right side, and what's happening on this side is the left side. The right atrium. That's correct. The right atrium. Very nice. All right, and that would be step 2, the right atrium. All right, blood then will move from the right atrium into the right ventricle. The right ventricle, right here. And through what structure? Through what structure?
Artery.
valve, and you have to know the name of the valve. Can we draw a few muscles here? These are called papillary muscles. These are papillary muscles down here. Papillary, finger, papillary muscles. Right here. These are papillary muscles. This is it's called the tricuspid valve. Tricuspid. But it's also the right, look at this you guys, it's the right atrial ventricular valve. It's the right atrial ventricular valve. Okay? And the valve is attached to these papillary muscles with these strings. Cordae tendineae. Tendinous cords. That's these guys right here. Tendinous cords. So far, so good.
Yeah.
And so so this chamber then would be number 3.
The left atrium.
Yep. That's the right ventricle.
That just said third chamber.
Oh, sorry. Third step. Step 3. Okay. All right. So if we draw an arrow here, here's our arrow. We're going through and into, I'll have to erase some of this. Here's our arrow, and we take a turn, and we turn. It comes in, we take a turn, and we go up through valve. This is a second valve now. What's this called?
Pulmonary.
The pulmonary. Yes, the pulmonary valve. Pulmonary valve. This is the pulmonary trunk. Trunk just means a short vessel, the pulmonary trunk. And this is the pulmonary valve. Or maybe I should write that over here. Pulmonary valve. And that's this right here. Or you can call it the right semilunar valve. The right semilunar valve. Half moon. The right semilunar valve. Sounds good? So, there are actually 2 atrioventricular valves. There are 2 semilunar valves. So if you're going to use those 2 words, you have to use left and right. If you're going to say pulmonary valve, then there's only one, so you could just say pulmonary valve. both ways are fine. Okay, now, so let's draw that. So this is going behind, or actually this is kind of going in anterior. However, it's sort of hard with the cut. This is the direction that blood is moving. Now blood is exiting. Blood is now exiting the heart. Okay. So, so since this is a blue vessel, should we call this an artery or vein?
Vein.
You'd think it should be vein, right? It's blue. Veins are blue. Actually, that's not true. That's not the rule. The rule is artery away. Artery away. Artery away. All vessels that move away from the heart are arteries. Every single one. Most, 99%, most vessels that are moving away from the heart are red. They're oxygenated. But these are the only exceptions, the ones that say pulmonary in front of them. If it's a pulmonary vessel, it's the opposite, because we haven't yet gotten the oxygen yet. So once we're through this little area, all these, then it's what we would expect. Arteries are red and veins are blue, except for this little area, because remember, the heart doesn't oxygenate anything, the human heart. It's the lungs that give the oxygen. So this is the left pulmonary artery, even though it's blue. And this is the right pulmonary artery. You guys see that? That make sense?
Yeah.
Then all we gotta do, we do gas exchange right in here. Vein and blood coming back. Here's the blood coming back. Blood coming back. And we should make some steps here, right? So we had the vena cava, step 1, step 2, the right atrium, step 3, the right ventricle. So let's use the pulmonary trunk as step 4. So here's step 4. Pulmonary trunk. And if we want to use these also, so 5, pulmonary artery. And what did you notice about the color of the blood? On our way back, on our way towards the heart, not all vessels that are moving towards the heart are blue. Because this is a pulmonary vessel. So here's step 6. And take a guess. What's the name of that vessel? It's the left pulmonary artery. No, vein. It's the left pulmonary vein. It's the left pulmonary vein. Because it's moving towards the heart. It's not, it doesn't have anything to do with color. Not all veins are blue and not all arteries are red. If the word pulmonary is in front of the word, it's the opposite of what you would expect. The rule is artery away. Well, this is moving towards the heart, so it's not an artery, it's a vein, even though it's oxygenated. Make sense? All the blood from the right side, from the left side, all the blood that's moving now away from the lungs and towards the heart gets dumped into this chamber right here. Even this stuff over here. And that chamber is the what's the name of this chamber? This now is the left,
vein,
the chamber, so left
ventricle.
atrium. This is the left atrium. Here's the blood moving in. And let's call this step 7. There's step 7. All right. The blood in there, again, moves through a very similar, and here we have some papillary muscles. And we have these tendinous cords, cordi tendini. And the blood sort of does the same deal. You got this arrow, bends, takes a turn. Some turbulence. Okay. What is the name of this valve right here?
Left ventricle.
This is the bicuspid. Or you can call it the left atrial ventricular valve. The left atrial ventricular valve. And just in case you find it on exam, there's actually one more. This is also called the mitral. The mitral valve. So blood re-enters the heart into the left atrium, goes through the bicuspid valve and into step number 8. This is our, what is the name of this?
Left ventricle.
This is the left ventricle now. Left ventricle. Blood takes a turn and goes up through another valve that kind of looks like this. And it's kind of right, it's hiding. It's right here. And what's the name of that valve? If this here, this is the
Aorta.
this is the aorta. And if this is the aorta, then that must be the aortic valve. Or you can call it the left semilunar valve. The left semilunar valve. Then blood moves like this and up through here. And down. All right. That's the first step. Now that we sort of know how blood moves through, now we're sort of, we've just gotten a handle on orientation. We've sort of oriented ourselves. Now we got to talk about how the blood does it. Did you notice that we have a really, really thick walls, especially here? And look at how thin these walls are over here. And what do you notice about the chambers then? Do we have more volume over here or more volume over here? More volume on this side because the muscle over here is taking up the volume. It's actually a little bit. Why is that? Why are the walls so thin on this side and so thick on this side? What does that have to do with anything?
Isn't it because the blood is pumped?
Yes, this side of the heart, when this thing pumps, when this thing contracts, it has to pump blood up and up to the head and down the arms and all the way down to your toes and all the way back up to the heart again. This one chamber has to do all that. Pump all the blood all through your millions of capillaries, all the way up to the head, the arms, all the way down to your toes, and all the way back from your toes, all the way back up to the heart again, in one single beat. And you're going against gravity. There isn't anything else that pumps. There's not another heart down at your toe that pumps blood. We only have one heart. Now we do have things that help out, but it's mainly this one left ventricle that does all that. That's why it's thicker. Over here, when this thing contracts, where does it pump blood to? 2 inches away to the lungs. That's not any lower or higher. The lungs are very, very close by, and so the thickness of this wall can be significantly less. You don't need as much muscle. You want your heart, when you work out your heart, you want your heart strong, but you also want it flexible. Too thick of a wall will decrease flexibility. Too thick of a wall will decrease flexibility. When you have morbidly obese people, the heart is forced to pump blood to every single cell in someone that's very, 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 very large, just like a very thin person. Well, that's difficult. That's putting strain on the heart. So what does the heart do to get blood to every single one of those cells? What does the heart do?
Strain.
It's forced to enlarge and get thicker and thicker and thicker to try to compensate. But what does that do then? What does that do in turn? What does that do? It becomes less flexible. And because it becomes less flexible, it's forced to work harder. And also, when it's thicker, there's less volume. There's less blood that can sit in here. That means that the heart has to pump fast and even harder. So what does that do in turn? It's a domino effect. So now you have less blood that even sits. So per time that it beats, it's the volume is less and less and less. So it has to pump harder and harder and harder. It's a cascade effect. It's a domino effect. It's a downward spiral effect.
What about clogging in the arteries?
And clogging also affects.
That's one question.
All that cardiovascular resistance puts a strain. So what you eat. And not to mention there's turbulence in here, which is also another strain. So it's important to work out the heart, but not so. But the heart is the one exception to our muscles, right? It looks so good to be, have arms so large, but having a heart so large is puts a strain on it, and it ends up being an unhealthy heart. All right. When blood enters the right atrium, 75% of this blood drops down into the right ventricle only by gravity. 75% of this blood opens up these valves, and if you want to see what the valve looks like when it's open, it just looks like this. Just by gravity. Now, when blood enters the right atrium, is the right atrium in systole or diastole? Is it contracting or is it relaxing?
Relaxing.
It's relaxing. It's in diastole. It's in atrial diastole. It's an atrial diastole. Like open arms. How can you receive someone unless you have open arms? So the heart, so this chamber is larger because it's relaxing. It's not contracting and squeezing, it's larger. The only way you can receive blood is if you're relaxing with open arms in atrial diastole. The last 25% drops into the right ventricle when during atrial systole, when the atria are contracting. 75%, 25%. You guys got that?
Yep.
All right. So, once 100% of the blood is down in the right ventricle, and by the way, as this is happening, what is the right ventricle, or what are the ventricles in? Because remember, what's happening on the right side of the heart is also happening at the left side at the exact same time. When 75% is dropping in, when 25% is dropping in, the right ventricle is in systole or diastole.
Systole.
Contracting or relaxing? Contracting? Actually, it's not. Because the right ventricle is also receiving blood. So, like open arms. How can you receive blood if you're squeezing? You have to be open.
So it's not
Make sense?
contracting.
So it's not contracting. It's also in diastole, just like this. So both.
That just said
The first 75%, this is in diastole, and the ventricle is in diastole. For the 25%, this has to squeeze. So this goes into atrial systole, but the ventricle is still in ventricular diastole in order to receive that last 25%. Does that make sense? Now, after the last 25%, what's the percentage of blood that's in the ventricles? 100%. Now we have 100% blood down here. Everyone cool? Does that make sense? Now we can begin ventricular
diastole.
systole. Now we can begin ventricular contraction, ventricular systole. Okay? What happens to the volume? What happens to the amount of space in the ventricles as we begin ventricular systole. It goes up or down?
Up.
Increases or decreases?
Decrease.
It goes down. It decreases. The room inside goes down. The room goes down. So what happens to the pressure in here?
The valves close.
What happens to the pressure?
There's no-
Well, which way does the blood move? It wants to go here, right? Well, this valve is still open, right? We didn't say anything about closing. So the blood can move one of two ways out of this chamber. It can go back the wrong way, or it can go forward the right way. And it tries. It just moves. The blood doesn't have a brain. It just moves whatever direction it can. And therefore, when it moves this way, what do you think happens to that valve? It
Close.
closes. And that is what makes the first heart sound. S1. Lub.
Look,
Lub. S1. That's the closing of the atrial ventricular valves. That shutting makes the first heart sound. Lub, lub dub, lub dub, lub dub, right? The first one. Now that this is closed, now that these are closed here, now pressure will in fact begin to increase because now we have a closed system. And the ventricle continues to squeeze, 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 squeeze in systole, right? Finally, what happens then? The semilunar valves open. Now the semilunar valves open. Semilunar valves now open, and blood is finally able to. And the valve and the ventricles continue to squeeze, 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 squeeze until there's no more blood. Actually, there is still always some blood remaining, but we won't get into that right at this moment. All right, let's stop for a moment. Step one. Where is the blood coming from?
superior,
The vena cavas, superior and inferior vena cavas. And they get dumped into the
the atrium.
the right
Atrium.
atrium. And then it goes through the
Right ventricle.
the
Cuspid,
the tricuspid valve and into the
right ventricle.
right ventricle. And then blood moves through the
Pulmonary trauma.
pulmonary and aortic
Valve.
valves, and the blood that's moving this way enters the pulmonary arteries, and the blood that's moving this way moves into the
Aorta.
aorta. And if we're just going this direction, these two are then the pulmonary
Valves.
veins, and blood then moves into the
Left. ventricle.
left atrium through the
Bicuspid.
bicuspid valve, or the left atrioventricular valve, or the mitral valve, and into the fourth chamber, which is the
Left ventricle.
left ventricle. And then, of course, out the aorta. First, we have the first blood that drops down is what percentage? 75. And when the blood is when the blood moves into the right atrium, is the atrium contracting or relaxing?
Relaxing.
It's relaxing. And when the blood moves down, is the right ventricle relaxing or contracting?
Contracting.
It's also relaxing. How can you receive blood if you're doing this? Right? It's also relaxing. It's an atrial diastole. The last 25%, how does the last 25% move from here to here? The atria must must contract. You have to have atrial systole. But the ventricles are still still relaxing in ventricular diastole. Then the ventricles begin to contract. What's the very next thing that happens? The tricuspid and bicuspid shuts, making lub, S1, the first heart sound. Then what happens? Finally, the semilunar valves open up and blood begins to move. Eventually, now, once all the blood moves out of the ventricles then begin to move into ventricular diastole. Ventricular diastole. And what do you suppose happens when this opens up? Would you say that there's more pressure here than here, or more pressure here than here as we move into ventricular diastole? More pressure up here because now there's low pressure down here. Then eventually there's high pressure here and low pressure here. Well, blood always moves from high pressure to low pressure. Just like when we were contracting, the blood wanted to go from high to low, high to low. Therefore, if there's high pressure here and low pressure here, which way will the blood want to move when the ventricles begin to relax? Back down the wrong way. Therefore, the semilunar valves shut, making S2. Or we can say up. That's the closing of the semilunar valves. Lumped up, lumped up, lumped up. S1, S2, S1, S2. Blood always moves from high pressure to low pressure. Always. Even in weather. Do we want to be in a high weather and high pressure system or low pressure system? Do we want to be in a high pressure or low pressure? Where's the danger? When the weatherman says we have danger, we must be in a low pressure because then we're going to get weather. We're going to get storms coming into our area. We want to have high pressure, at all times. If we don't want weather. Anyway, blood always moves from high pressure to low pressure, which is why this moved from here to here also. How does the first 75% of blood move into the ventricles?
Gravity.
Just by gravity. And the last 25%? By contracting the atria. Once we move up and out of the aorta and down, where is this blood moving?
One goes up to the brain.
Up to the brain, the arms, down, all through the chest, thoracic, abdomen, all the way down to the toes. This is called the systemic circuit. Any blood that moves away from the heart but not to the lungs, it's called the systemic circuit. System, to the systemic circuit. Systemic circuit. However, we do have some blood that moves to the lungs. This stuff right here. This stuff is called the pulmonary circuit. We have the pulmonary circuit and the systemic circuit. All right, makes sense? Now the heart does get some help. Every time that ventricle relaxes, every time those ventricles relax, blood wants to move the wrong way. The blood moving up the legs do get some help. And with valves and muscles. If this is a blood vessel, the valve always points in the direction of the blood flow, of the direction that the blood should move. And these valves are just made out of tunica intima, which is just the inner lining of the blood vessel. Blood should just move like this, going up. Well, we have muscles like the gastrocnemius. When you walk or step on your tippy toes and relax, contract, relax, or just walk or run or jog, any type of exercise involving moving your legs, puts pressure on the valve, puts pressure on those veins coming up. And we have these valves that look like this. Well, the blood that's in here can move one of two directions. It can either move, it can either try to go this way or this way. But what happens, you have high pressure here, high pressure because we're squeezing, low pressure, this valve will shut and blood is forced to go up in the right direction. Therefore, exercise assists the heart in returning blood to the heart. Anybody know of people with varicose veins? It's extremely painful, and it's very bad. You have to wear compression socks. There's really not much you can do. What happens, and it's another a downward spiral effect. What happens is you get this when you're not moving your legs, when you're not contracting and relaxing, your muscles, the valve begins to fail. These vessels weaken and they begin to increase in size. And what happens then is these valves they can't reach. They get enlarged, which cause the blood to pool and pool and pool and pool, which puts even more pressure. And eventually you get these veins that are coming out of your body. You could see them, and there's nothing you can do except for try to use compression socks or remove them, but there's just way too many of these veins. We can't remove every single one. And so that's why it's important. Don't stand in one spot for a long. Don't stand. They say, oh yeah, stand up offices, right? Right? Because sitting is bad for you. So stand up at work. Well, standing has other negative health disasters. Yeah, sitting. What does sitting do? Text neck. Right. You're compressing your viscera. While standing. So the only thing you could do then is to be running in place while you're. But seriously, yeah. So that. And there's one more thing. We talked about these papillary muscles and these chordae tendineae and these valves. When the valve shuts, there is a lot of pressure in here. There is a lot of pressure in these ventricles. The papillary muscles hold on to these cords, which are holding on to the valves. And if you were to snip these cords, or if these muscles weren't functioning, if there's somehow a disconnect, that there's so much pressure, the valves would blow backwards. But you only find these kind of valves here and here. These ones don't have any strings attached. They're a little bit smaller, and they're just shaped differently. but smaller valves in smaller tubes. These are much larger, so they need all these strings.
How we understand a person who is doing physical exercise is increasing the oxygenated or oxygen? How we understand the situation is they found?
One more time.
Heart pumping. A person who is doing physical exercise.
Yeah.
Yeah. How we understand the situation? Oxygenated blood. It is, which one is more important for us? Increasing the oxygenated or deoxygenated?
Yeah. The oxygenated and the deoxygenated, they really don't change much. They don't really change, but what's inside the blood changes. So as you increase in exercise, depending on the type of exercise, you can increase myoglobin, which is the oxygen carrying molecule in muscle. You can increase mitochondria. Depends on your exercise. Are you doing high intense, short bursts of high intense workouts, bulking up, or are you doing long distance marathons? Are you sprinting or long distance marathons? Was that kind of yeah. But the amount of deoxygenated and oxygenated blood, they don't really change as you increase in fitness or decrease. You always have, you get real strong, you get real fit, well, those cells are going to be working harder and they're still going to make waste. They have to get rid of the waste. So you don't really, it never really changes. But if you can have more oxygen and less deoxygen, that would be great, but there's not really a way to do it.
Yeah, a person is doing physical activity always, the brain pumping, like inspiration, expiration, is that easy? That's because of the heart muscle?
And the lungs. You can't, I mean, there is a way to increase the carbon dioxide, of course. Just hold your breath, or keep rebreathing your air. Keep breathing in a bag, yeah. But that's really the only way that you'll, which is not good, of course. So, okay, that I believe covers a good chunk of the cardiovascular system, and that is how blood travels all the steps through the heart. And remember that although blood starts here and then moves to here and then here and then here and then here and here and here and here, whatever is contracting on one side of the heart is also contracting on the other side at the exact same time, or actually at almost the exact same time. There's a little bit of a delay because of the electricity that flows through the heart, through the SA and AV nodes. All right, thank you for that, and that concludes this video.